Alrighty. Going to be getting everything situated here for a late night Quail stream. Specifically, I'm going to probably work on the WAD idea that was kind of brought up today during the conversation. So, see how far I get. I don't plan to stream for too long, maybe an hour or two at tops, unless I hit a big issue. And also going to be experimenting with the new setup that's super comfy for me. So we'll see how that looks and works. And yep, it'll be starting here just one moment. I'm just trying to get everything kind of situated real quick. Let's see how this looks. I'll save this to YouTube later, so if you watch this on YouTube, hope you learn a thing or two. All right, let's transition and see how it looks. I think it might look pretty good. I think my audio levels are decent. I can see chat and moderate. And I'm super comfy. Cool. So, hopefully I'm not too quiet. Shouldn't be. Currently, Quail has some local modified files. That definitely needs some TLC. But I'm not too worried as long as it compiles. So let's do a test. We got a syntax error to fix real quick. Looks like I was starting to use a texture path, didn't finish that. What else we got going on? And wow, this file is not done at all. Cool. So now we compile at least. There's been a bunch of changes I've done over time. Hopefully this is viewable. The resolution's a little higher, so it it's hopefully zoomed in enough that you can actually read what the heck's going on. But the idea for today is that the world doc has world com notes, and I've noticed that Tenaris has a WAD format, which is apparently a reference to Doom. And there's my first ban. I don't think you guys see chat, so cool. So let's see if we can find in this thing. I think it was the Tenaris map editor that had an example of how WADs work. You can see right here. So I'm going to write something similar. To do so, I'm thinking I could make a new format command, probably based on convert. I need to scoot over a little bit more, I think. There we go. And so this convert copy will be renamed to WAD. Find all instances of the word convert. Do a sensitive replace to WAD. Okay. Now if I run, there's the WAD. Convert WLD to WAD. Probably supports these three formats. Probably makes the most sense. And that looks good. this has dir right. It's probably going to be WAD right. However, I'm probably not also going to use the Quail type. So it used to be Quail was like my generic format that everything, kind of conformed to. But my new style can read raw data like this. And like this even is a problem because I iterate all the fragments and I build them into this Quail format. But I don't think this is right. I don't think this is the right direction. I'm going to open up a new tab and look at, I think it's Sage. And I was doing some comparisons to how he does a class of world. And good old JavaScript. So you got a world class here. You have a reader identifier string. Yeah, so you see here there's like BSP tree fragments, skeletons, track definitions. See how there's like totally different format types? I'm probably going to need to write a new style, which I think I was actually starting right here. So if you see, yep, this is one-to-one with this. So what we'll do is world will have an exporter to WAD. And so in this thing, world can write a WAD to a writer. Something like this. That's a tongue twister. Okay. So when we write a world file or a WAD world blah, arguably, okay, so a raw world fragment, right, has inside of it fragments that are ordered in a very specific way. The world format has both fragments and decoded fragments. And then, of course, WAD format will be one-to-one to world. So the problem I'm going to hit is, should WAD go to the decoded format first or to fragments? I want to say we should actually focus on making fragments. Let me look at how these fragments look. Because what these do is they'll have like a default palette, world vertices, the number of vertices, and then just the number of entries. And then it goes to the next thing. And some have end definitions, but essentially get like light definition, end light definition, 3D sprite def, end sprite def. And I believe like world tree. So that's cool. They have like an index of the counter, and then it spits out each counter entry. So it's a pretty straightforward type. Ooh, what is this world wall stuff? Interesting. And obstacle is a new type that we've never seen. We've never seen viz tree as well. We do know the term region, but you can tell that this is kind of unique. However, This gives us a ton of hints of how our new WAD type should be defined. Because we could arguably do not insert any statements between this line and the default palette. Okay. I don't know if I have WLD CLI compiled. Looks like I do. Cool. So with World CLI, I can do a quick exploration. I'll actually start up terminal. What we can do is go to source. Is it? No, it's source EQ ROF. I don't know if I have any decoded files in here. Let's see. We'll take something simple. Like said car. Is Quail in? No. Quail extract. What was it? Said car? Yeah. So now we have this extracted, which will include the world file. And so now we can run CLI, and I think it's just explore. And this will show me the fragment structure. And we can assume the fragment structure is also how these WAD files are defined. So like BM info is essentially the default palette definition, and then like world vertices. You know, they define all their sprite definitions. And then when all the definitions are done, it creates tracks. So one slight challenge we're going to hit is if we define things the way this is going, we're going to have a weirdness when it comes to Python reading a freaking WAD file, because Python is going to be loading into Blender, and Blender doesn't have like the same formatting. What is the extract command? So this is the JSON exporter that World CLI has. And you can see here, he defines header and then an array of strings, which this is just the name string system, which makes sense. Can I collapse JSON? No. Do I have a JSON thingy? Why are there like no results for JSON? Here's a beautifier, prettifier. Meh. Anyways, I would love to be able to collapse these. It's kind of weird you can't. Here we go, fragments. And then I can jump between fragments. So this is an interesting way. We could probably replicate something like this. The problem with this style though is notice how it's like frame references and then it indexes the null. So in Tenaris, we have like default palette file, and then we have vertices, and we have like sprite definitions. And then it has a vertex list. I'm trying to see if there's any referencing going on in here. Back tree, front tree. Because it honestly looks like WAD is essentially taking the data on top and the data down here, and it's creating this like definition file. So BM info is, yeah. I'm going to share this stream just in case anyone's late at night. So, yeah, I have a feeling based on how this works that these definition headers are essentially designed to be tab-based like this. And I feel like I could make this work really good with Quail or with Python as well. So it is tempting. Okay, so with this in mind, okay, this means that I will have to I'm going to go ahead and just copy all this for reference. Okay. What I would say is that whenever world is being written to, there's all these different, definition tracks, and they're essentially writing out all the, bitmaps and material references and everything into declarations like this. That is, I think, what the source is doing. So I'm pretty sure I can replicate this, and it probably is going to be more accurate to what EverQuest actually does. I'm going to go ahead and work towards that in some form or manner. So to start, we'll do something similar to this where it's like we're going to start a text file, which we already did here, and we're going to start writing to it lines of strings. So unfortunately, when you write, it's just going to want a byte slice. That's okay. Yeah, we could even just put in here, something similar to what's here, which is CPI world. Just like tabs. Now it's just spaces. And I don't know if we want to use the word Sony 3D, but we could. Well, because we're doing it like that, we'll have to do that. Okay. Do something simple again. How about Quanos 2D to throw them off? That's an option. Um, I'm pretty confident if I write this new kind of pseudo WAD define type, it's going to be easier to debug because um, you can tell that fragments kind of have like a definition list, and these WAD files are going to be easier to navigate than the reference lists that fragments currently do. So, pretty sure this is going to be a good route. We could even write some of these comments. I'm not going to bother for now. Okay. So if we go back to what the JSON file shows, I'm pretty sure the header information, some of this we may need to keep, but for the most part, these are going to be defined inline as the definition gets to those specific points. I don't even think string count is going to need to be there because this whole string definition and all these definitions here, you can tell these are likely all auto-generated. You know what I mean? Especially when they're like predictable patterns like this. This is likely one definition in the WAD, and then they just auto-suffix the file names. You look like you are building a super simple S3D world tonight. Kind of. What I'm actually doing is I'm writing a WAD converter. So I'm trying to make an intermediary format that world files can be exported and imported from. That's similar to what Live has, or I'm pretty sure is what the EverQuest really is using behind the scenes. So like Max3D, when you export, generates a WAD file, and then that WAD file goes through what's called WorldCom, and that converts it into what we see, which is the .world. And so these definitions have certain patterns for like how they reference and stuff, and it's a lot easier to manipulate than using fragments because fragments are so hard referenced. So my theory is I can write something kind of similar and get the get more benefits out of it. And so to kind of reverse engineer that, we have all these different fragment types and strings and all this stuff that like this is from World CLI, the different fragments. So bitmap definitions follow with a simple sprite definition, and then, ultimately declares the simple sprite. What I'm pretty sure is happening with this is that the WAD type is actually a clone of the Doom WAD, because the Doom WAD does something similar, actually. I'm pretty sure they kind of just borrowed it, because you think about it, EverQuest came right after the Doom era, and I'm pretty sure Tenaris did too. So I think True3D, when they started making it, they used WAD as their just generic file type for like world data, world area data or something. I don't know what the acronym's for. So let's say we declare a type, and we're going to just call it bitmap info. Okay. And bitmap info, we always think of it as BM info, but it actually has 3 parts to it. So we're going to iterate every material, which we have as material list, and essentially say, for every material, range over the material list. And I think right now material, it's not very well defined, is it? It's trying to write it for me. I wonder why material is not well defined. How is this actually defined? Oh, the struct is literally empty right now. How is it defined in here? So material list have indexes. Oof. This is like a raw material type. I'm looking at Sage, by the way, for reference. But it's importing this material. And a material apparently can have quite a few property types. This is like your shader, brightness, all this fun stuff. Yeah, so you have material def. And that's actually what discerns that info. And this material def is name reference -28, which is this. So the MDF is the material definition. The sprite is the bitmap definition. And then ultimately the object is the, declared on the top. So I bet you how this looks in, writing is that you have bitmap info, and we start with declaring the definition name, which you can kind of see over here like this. So it'll be something like, there's some tabs and stuff. We can clean that up later. So we just go write a, I'm going to make a helper just to help me simplify this call. We're just going to call this, write line. And you pass it a writer and a string. Yeah, you exactly know what I'm doing. And I'm going to ignore the error or the return error for now. And all this will do is, this isn't bad, but it's not what I want. It'll be like bitmap info. I don't think we need an index, actually. We can just put bitmap info. And then we can, we might actually double line it though. Then we actually write the material tag, which is probably something like this. And it's quoted. Yep. You don't need a new line. And then, yeah, we declare the name. Simple as that. And then we go back to material. And this needs a name. And that, technically material may not need. Yes, I do think it has a name, but it's not declared on this version. And that's because of how we do our, reverse engineering stuff. That's my theory currently, though. We will see. Because name is a tag actually internally. And then once you have the, the tag, so in this case, ambient light can be referencing another light type. But because we're doing like a material definition, let's just assume this is correct. And continue. Does region have an end? Let's see. Yeah, end region. So when this is all done, we write a end bitmap info and probably double new line like this. I don't know why you're erroring. Am I missing a... Oh, it's because I have a sprintf. Yeah, these can actually just be like this. So yeah, what this will do is we're going to put all the different material, texture referencing, and all the definition data for like shader and everything inside of these bitmap infos. And this essentially builds out all the fragments that you see here. Because if you look at the ordering of how materials are defined in the fragment style, you can tell this is basically what's happening. So you have bitmap info, simple sprite, material def, and this pattern is everywhere. So we're going to assume all this data is stored in this one chunk of entry. So let's go ahead and look at this. So BM info has name. It has an array of entries. So how do we do an array with this style? It looks like each array can be defined as a sub-element. So like here, a region will have multiple walls defined. I'm curious though, like this said CH001, is this defined anywhere else? Yeah, I don't think so. I might hit a problem with this approach I'm about to do, but we'll assume for the time being that this is correct. I'm going to add some little tabs just for testing. All right, so going back up here, we're going to now iterate all the material arrays if we need to. I think these are the texture references, essentially. Because this is not defined anywhere else. So basically, yeah, exactly. It knows what I'm doing. I don't know if textures have declared names. It sucks we only have this WAD. I kind of wish we had some more. Let's look like a actor. We do have tag. Let's just assume what these will do is something akin to this. Number of textures, and then you would put, yep, you got it. It'll put the length of textures. And then after that, it iterates every texture as a sub-element and has an index like this, like these world nodes. And then when they're done, it's essentially the end of X. You know? And that basically gets us so that every, like for animated textures or ones that have multiple references, they're just arrays within the bitmap info definition. And now we got to get the texture array, which we call material list here. Okay, so he just reads them all and puts them here. This code's so much a pain to like discern. Here's the material definition types. That's great. But like, where is the texture names getting defined? So you see it processes the fragment of bitmap name by using this, and then it just decodes it. So yeah, basically when I read and write these, it's going to be really interesting. WAD read and WAD write are going to be very different because of how fragments load. Which does bring up a point. Let's figure, okay, so from a Blender perspective, all it needs to understand is the WAD type, how to read and write it, right? It'll never understand the S3D style. Quail, on the other hand, so this is in Python, right? Quail, on the other hand, needs to understand the WAD type, right? Because it needs to be able to read and write it. It needs to understand the world type because it needs to read and write it. So the Quail code is going to be pretty much doubled. But I think WAD as a whole should be easier in Python to just load because basically all the raw data is there. And then Quail, while it does world reading, it'll take those fragments and put them into that intermediary format. And that intermediary format we'll call the the world struct. This is what needs to be. World has to load into world struct, and output is WAD. And arguably WAD needs to go into the world struct as well. And be able to write out as world. So like these two flows need to be captured as well. Which, yeah, so this part shouldn't be too hard. And this is technically just fragment decoding. And the world struct is likely going to be what everyone else already defines currently. But I kind of hope, I would like to be able to go world to like WAD type struct. You know what I mean? That feels better. What I mean by that is, you see how like world is so gross? Like, because you have like the fragments and you have all these definition lists and they're all kind of just a mess. It would be nice if we just start working on a WAD type instead. And the WAD type can write to fragments. And that's ultimately what WorldCom does currently. So let's assume we do that, okay? Then I don't have to touch this as well. So we're going to make a WAD type real quick. And we're not going to get too deep in this part yet. We're just going to go over here and do a WAD. I think I use decode. It's been a while since I've... Is it read? No, it's read. And currently we're going to focus on WAD write. So WAD type EWAD write. Well, and it should just be right. Yeah. Yeah. And at this point I can paste all this junk. Oh, I don't need all this. I'm missing something. This all should be here. Why is it not happy with this? Expected semicolon. Oh, it's because it's a func, not a world type. There we go. All happy, formatted and cleaned. So let's go ahead and I like how small my area to text or to actually code is. But nevertheless, I'm going to go ahead and hop in here and we're just going to make a materials type, which is just a literal array of material. And then this material, for the time being, we're just going to define it here. We arguably are calling this bitmap info. Let's do that actually. Sure. No, we're going to call it material. Even if this is called bitmap info, we're going to call it materials. Okay. So Bitmap info is basically bitmap info. There we go. So we have tag. Tag is also known as name. Okay, so we're going to go materials. Probably should make it lowercase. I don't normally want to export this outside the scope. Okay, then we have tag. And then we're going to have an array of textures, which I believe is only going to be a string. We can verify that here. Or actually, no, we can verify with the JSON. Where's the JSON at? Over here. So if we look at all the funness of this, you can see that each texture entry only has a file name. So basically, this is just a reference of textures, and each texture name needs to be unique. And this is just a way for us to define so what we can do is this, I, and then we can write, is this saying file name? I think it will probably be called texture file. Let's just do that. And then we put in here texture. It's a bit overkill, but I think this is what's happening. This is cool because if we do end up needing more metadata and textures, all we have to do is add more lines to this. So it's like flexible, even if it seems very wordy with what it is for now. Okay. So now we got bitmap info essentially converted in our new style. And so next, we're going to go back over here. And we'll just keep going through here. So this essentially clears this. So like texture entries is what this entry count is. Or num textures is this. And texture index are these with the texture file definition. Cool. And then we end texture. Or end bitmap info after all the textures are defined. However, there's more to a definition, and that is the sprite definition. So how is the word def worked on here? Yeah, so you see how this is like this? What we'll probably say is 2D. Okay, so we're in the material tags. Default palette, I think. Honestly, I think what's happening here isn't this simple. It's going to be yeah, this is what I think it's really doing. Number of bitmap info. And then here's all the bitmaps. This has an I. Then there's a line that says bitmap info D, which is I. Then it puts in the material tag. Then it says number of textures. And then there's an end bitmap info, which I think all of these ends also have the index. Let's see if that's a pattern or not. Yep. Okay, so this will have something akin to this. Okay, so number of bitmaps info, then bitmap info and bitmap info clean. Unexpected 4 at the end of statement. Oh, it's because this needs an extra parentheses. Okay, so bitmap info, material tag, number of textures, boom, 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 and bitmap info. And that would be the same structure as over here. Cool. Next, we have these sprite definitions. And for these, I have a feeling it's going to be very similar to this pattern, which is right line. Well, actually, it's going to be in bitmap info. We have number of textures. So here's all the textures. Okay. Now we have a new chunk that is number of 2D sprite definitions. Yep. And then this will be sprite definitions. Sprites would work. I don't mind that word. We're going to actually just call it a sprite. Sure. I don't know if that's going to be its tag or not, but we'll assume it's correct. And this is going to have all sorts of cool info because it has its own unique name reference. So yeah, tag is correct. And yep. And then we have the sprite definition X. Yep, you getting this. Then we have a tag. And then we end. And there we go. That's basically what's happening here. All right. So we define the number of textures. We define the number of sprite definitions. We've added in the tag, which is the sprite name. But now we have flags, which in this version, in this version, what is a tag? Or a flag? Does it have the word flag? Is it like render? I think it's render method is what this actually is. And also, I don't think this is a sprite tag. I think this is just tag, isn't it? Oh, okay. It keeps the same name, sprite tag. So this will say actor def or 3D sprite def. See that? So this is essentially what we're doing right now, but we're doing a 2D sprite def. Yep. Why? Oh, am I missing? Okay. And so sprite def has a sprite tag, which is apparently called 2D sprite tag. Apparently not quoted, actually, which is interesting. This is quoted, but this one is not. Is that because it's defined earlier? Oh, heck, there's literally a sprite def. Oh, no, it's just 3D sprite def. Okay. And it has a tag, but then that is referenced as a actor def. Okay. I'm getting this. Learning a lot. So, N2D sprite tag, and then we have 2D sprite tag is this. I kind of want to not have quotes on this one, but who cares? We're just going to have it like this. It looks like it's consistently inconsistent anyways when it does all these definitions normally. So it doesn't matter. But now we got to come back in here and basically say, okay, we need the frame count. And that will be the frame count. Go back to the WAD. And a sprite has a frame count. I don't know what current frame is and if that's truly needed. I think it is. Let's just put in current frame. And let's put in sleep. And frames. Which, okay, wait. So frame references a frame index of another. What? That's gross. I'll have to double check this. Because this is confusing. We'll have to look at this. Anyways, so now that we have that, though, we can come in here and do this. Now, frame refs is wrong. This also doesn't have sleep. But we'll assume this is correct, okay? So this is a sprite def. Here's the actual sprite. And again, the sprite has a name reference and then it has flags. So what's the difference between a sprite definition flag and a sprite flag? And how does that inference in here? So like if we look for 3D sprite, this is an actor def, and then we have a 3D sprite def. And then this is the actor instance, where actor definition has a 3D sprite def, then the instance of it has a size, and then the actual definition of the sprite is here. Notice that the ordering is super important. I think what it is that the definition is essentially the declaration that says, hey, here's something to render. But the actual rendering of it is the instance. And that's actually what simple sprite is. But see, simple sprite is literally just referencing itself. So when I build this out, like this is kind of repetitive. The only difference between these two is the flag. I don't think there's ever an instance where the simple sprite definition and the simple sprite, oh, the reference is just the index. Like this is literally the index of what element this is. So we don't need that field at all. Unless frame refs is something I'm missing. Unless this is like, so frame refs is 5. So confused here. Okay, so BM, this is index, what, 0? And then sprite def is index 1. This is 2. This is 3. So in other words, simple sprite and simple sprite def Those are just the literal indexes. We're just not going to bother with this right now. I don't think it's actually used. All right, so we got the sprite. We have the beginnings of it defined all the way up to sleep. We're going to ignore that. Now we go to sprite. So you can think of this as like the actual instance of the sprite now that it's been defined. And this is important because there may be cases where it can be instantiated multiple times. And the header on the fragment basically lists every definition. And then the actual instancing is later, is I think what's happening. So like you can see sprite references to. Okay. So we're going to continue with that mindset and assume what I just said is correct. So sprite, we're just going to call this number. Oh, wait. We're currently in sprites. Because all the sprite instances are going to be declared inline, what I can actually just do is iterate them and call them like instances. And we know that instances have flags. And like that's it, and a name, which means it has a tag. So is it called actor, or what is an actor instance called? INST. So in this case, oops, this still needs to be there, but okay. This will be INST. There we go. So each instance has a tag, has flags, ends. Your end needs to have an index though. Cool. And what that'll do is essentially give us sprite instances and definitions inlined. And when we defragment decode, what happens is we basically, we fill this instance, right? Like with all this data. And then, or we fill this sprite up with all this data in the instances. And then I think later it gets referenced by other elements. And that other elements, we can actually just inline it here. So cool. So that finishes simple sprite. Now we're up to material def, which is technically still all in the same perspective. I'm pretty sure material and sprites are in the same picture. Let's double check that, because right now we're up to index 28. So if we go back up, where's 28? Yeah, see, we're only here. I'm pretty sure these are all staying within the same perspective. So now that you've defined all the sprites of this bitmap, we now need to define all of the actual materials. So yeah, we may need to rename this. Just because there's so much bitmap data. Hell, let's call it bitmap info. I know I keep going back and forth, but. All right, so then we got materials. It's basically material. I mean, not wrong. All right, so these have tag. They have flags. They have which I think render method is, maybe it is render method. RGB pen. Brightness, which is apparently a float. Scaled ambient, which is a float. And I don't know what pair works like. It looks like it's a pairing for the material. Is that like that's probably the UV. So we're going to go ahead and do, we're probably going to regret this, but let's just say, can there be multiple material definitions for a single sprite is the question. I'm assuming yes. So pair only shows up if a flag is there. Yes. I assume you're saying yes to my whole, like, multiple materials. Can you see what I'm doing, by the way, Anarlian? I'm basically gonna write my own WAD format. So this is kind of an experiment, and I'm taking the WorldCom reverse engineered crap here, and I'm going to basically try to figure out. So this is probably an XY definition, actually. So we'll keep it like this for now, and we can tweak it later. But yeah. So what happens next is that we write a line, which is exactly number of materials. We iterate it, and we give it an index. We put it on here. We dump all this data. And we can change that one later, and we end the material, and that's it. So that essentially is what all this material junk does. And then this just gets repeated for every quote unquote bitmap info. And that gets us all the way to the next section, which I don't know where that is, but let's see what the next thing is that gets defined, at least on fragment dumps. All right, so now we have DM sprites. I'm essentially trying to reverse engineer the WLD format and make it like, in theory, what the WAD generator does. And so, like, when 3D Studio Max and you run the plugin that's in-house for Sony or for EverQuest, they generate a file that's similar to this, right? And that file I'm trying to kind of reverse engineer. And it's not going to be perfect, but even if I have something semi-similar, and you can see the symptoms of it, I guess you can call them, just based on how things come exported, and I'm pretty sure they follow certain rules, and that's also why you get a lot of like predictable data. So yeah, like you can see here, now we got a material palette. Interesting. Is a material palette always after a bitmap info finishes? Is that what's going on here? Let's check. No, bitmap info, bitmap info, bitmap info. These are like an array. And then we got this palette. Okay. And then we get the DM sprite. Is this palette DM sprite kind of common? Let's check here. Ugh, this is a pain to read. I was looking at the disassembly of a modern one. All the Eco Sky formats for this format are in there. Are they in like .wad format? And like kind of looks like what I'm writing in Aurelian? Because if you have those, share them on the client modding. I would love to, model it based on it, because I'm making a lot of guesstimations here. So Holy crap, there's a lot of entries. Okay, I may have scrolled too far. Shouldn't there be a way to like, yeah, okay, wait. This is what I should be doing. So we got material palette. We're going to just put this as like a to-do. There's one material palette, right? Then after that, there is a DM sprite definition for -500, which we'll go figure out what that is here in a second. Then, so this is 48, 49. Okay. Then there's a track definition. Okay. Then there is a track. Then there's a track definition. And I'm assuming it's just going to repeat this over and over. Okay. So what I'll do is first I'm going to go back up to the top at the strings, and then we're going to convert some of these. So like 500. This is essentially the said DM sprite. This is the track definition and the track. So you can see with like how this pattern is that each of these are declared in their own little chunks. Sorry, I'm catching up with you. I was looking at the functions for dumping the WAD format, I think. Yeah, material palettes is like the material list. Okay. DM sprite 2 is a mesh. One track def, yeah, per bone. So, yeah, essentially for now, kind of my goal, and I was writing this out earlier, is in case you joined later, guys, this is what, for Blender, I'm trying to just focus on, parsing these WAD files and writing these WAD files because they're a lot easier because they're kind of organized in a way that it's ready to go for, you know what I mean, an editor. While Quail will have to support both read and write of WAD as well as read and write of world. And so this is why I decided I'm going to basically make Quail use a new WAD struct, and essentially world to WAD is just taking the fragments and reconstructing, these new types that I'm defining. Because I feel like these WAD files are going to be easier to read than trying to reverse engineer these fragments, because I think the fragments are basically doing this just in a wonky way. So back to my topic here. So it looks like there's only one material palette ever defined, is there? Like, is material palette, there's only one on this file. Let me go find a different, one material per mesh. Oh, so this is actually part of the mesh definition. So in other words, we're done with the bitmap info. We can end this loop right here. Okay, so now we're on to mesh. And mesh, do you know what it's called here? I think it's called like 3D sprite info. Let's look here. No, wait, we're in the wrong file. So I think it's called 3D sprite definition. This is obviously a little different because this is like a zone. So you can see like world tree, sprite, BSP node, which is badass, by the way, that we actually see the BSP node data here. We got world node. Then we have regions, which I believe is just like our zone point region stuff right here. This may be interesting to see if this is the same. But we have walls. Then we have obstacles. These may be Tenaris exclusive. Then we have a viz tree. And more region data and walls. And then obstacles. Then we have an actor definition and an actor instance. So obviously this isn't one-to-one to what we need, but this does give us some really interesting hints on how mesh data now gets declared. So we're going to go back to 48, and let's assume that mesh is called a 3D sprite for now, and basically start a new one. I'm assuming there's going to be a like number of meshes. Yeah, exactly. And then there's probably going to be a loop. So let's go ahead and start writing some pseudocode up here. So like meshes is going to be a type of mesh. Wait, this isn't in bitmap info. This should be in here. Meshes. Sure. We'll make a type. We'll call it mesh info. And that'll have a tag. That's a pretty good safe bet. Okay, so now that I did that, this code should... Perfect. I know it's not called mesh info. It's probably 3D sprite. Or what you said, DM sprite def. Number of... what is it? DM sprite def. Well, I don't know if the def 2 is going to be there. We'll just call it DM sprite info for now. And because I feel like the definitions are going to be part of a sub element in here. And then yeah, there's a DM sprite tag, and there's an ending, and then there's going to be an end here. And then inside of this loop, there is going to be a listing of tracks. So we're going to go ahead and pop in some tracks. I don't know if any of this data is correct. I'm just throwing in whatever. Let's look over here first. So we know that mesh info has a material palette. So material palette is basically a texture ref to the other materials that it utilizes. Meshes by themselves are pointless. They are all tied to an actor. An actor defines particles, bones, and multiple meshes that are tied together. That is the top level structure with characters and equipment. All right. So I've noticed over here, they have actor definitions, right? And the actors reference a 3D sprite. And then the 3D sprite, which is called the camera dummy on this one, is where the actual data is declared. You can see here where it's like, you know, here's the tag, and then here's all this data, like the BSB node. So I think it's the same thing with how this is getting defined. What's happening is that it's declaring, which by the way, what is negative 439? Go find that. Oh, it's going to be positive though. 439 top reference. Come on. There it is. This is sed MP. So there's literally all of this, I'm pretty sure is in the same definition. You're thinking though that they can be shared. I should find another thing to extract to kind of help me with this. So let's do that real quick. Quail extract ch equip. Do I have ch equip? Or ch equip not here? What's a item? Okay, global object. Thank you. I was literally about to ask. Global object.s3d or g equip. Okay. So Quail extract g equip. Which one? Let's just do 2. Or no, literally just 1. There we go. What? Quail? I thought you were here. There it is. equip the S3D, go into there, and then I have a extraction command. Okay, then we can go ahead and grab that and kind of follow the same pattern and see how much it changes. So we are currently on, why are you giving me ... There we go, fragments. So here's all the bitmap infos, which we've already patterned. These probably are identical. So we're going to assume this is all good, even though this already looks like it may have more data. Nope. Here's the first DM sprite def. Yeah, so simple sprite, material define. Yeah. Okay, so we're at the material palette. So the question we were having is that you said that material palettes can actually cross-reference, which is interesting. Let me think about how I can discern that. You know what, for the time being, let's just write this and find out, because it should actually add transparency to problems, you know? So let's just say DM sprite info is the material definition. Let's assume material palettes are on their own. Okay. So if we do that, then what we need to do is, would I have to define all the, well, the material palettes are being referenced by the DM sprite, right? Is that what's happening? So like material palette is defined as 4. Yeah. My theory that I have kind of going is that when a zone gets generated or any sort of data, there's a bunch of WAD files, right? And it just basically does all this parsing and uses like tags as like unique IDs and just sort of looks for data and finds, you know, some validation and just generates a lot of junk. And that's basically what we're trying to figure out. You know, like that's what we're reversing from. So, yeah. All right. Continuing on, let's just go ahead and I'm going to possibly even skip material palette for a second until I get a little bit more confident. So what I'll do is just say material palette to do. And then same here. Because I don't fully know if this should be below Shmesh or its own. And if it is, I don't know the structure yet. I don't have confidence. So I'm just going to leave it like that for now. And, you know, go ahead and put this back here. Okay. So now we got material sprite info, or DM sprite info. And notice that DM sprite actually introduces with the definition. But if we go back to bitmap, bitmap has basically entry level info, like the material tag and stuff. And by the way, we need to rename this now to bitmap. And then it has all of the different sub elements getting defined within it. So let's assume DM sprite info probably has material palette inside of this, but we're just going to call, yeah, I called this meshes, but I'm going to call it now DM sprites. DM sprite info, which I know technically isn't a type, but I'm just calling it that for now. All right, so DM sprites have DM sprite, and these sprites have a tag like so. And there's flags, and then there's materials, animation, fragments, center, a lot of data, a whole lot of data. I should actually go grab the sprite. I need to actually open up my my declaration with libeq, which I think I actually have. Let me check real fast. libeq, yeah, of course. And then let's go find DM sprite, def2, and then let's look at the types that are known here, which is name ref, flags, material list, animation, some frags, center, basically all this crap. This is all going to be meta tags, and any of these sub elements, we can just declare them inline. Because I'm pretty sure if we go back to sed, once we get to 52, data strings, go back to fragments. Let's go to like fragment number 83 or so. We're just getting tracks, right? We're just track. And towards the end, it just ends. Like that's it. Literally track, def, done. So with gequip, let's go to the bottom. I'm just double checking if there's any other types we need to worry about. Like here's a material palette, DM sprite def, and so here we have an actor def, right? So we actually have actor definition instances, and we also have a hierarchical sprite. So this is very similar to here, where the geometry gets declared, and then at the very end, it basically says when you instantiate this, you know, here's the actor definition, and here's the actor instancing data. And in our case, we have the actor definition, which always comes first, and then we have hierarchical sprite, which is an interesting name. And then we have another def. The tracks are at the end of this. The tracks at the end are the animations. Oh, yeah. So you're saying, though, there's other types that I'm missing, obviously. But I'm just sort of glancing at this to kind of... Format is usually materials, meshes, base position bones with tracks for location, actor def, animation bones with their tracks, and okay. Right, and I imagine when you do a world declaration with zones, they have, you know, region data and other type of info that they declare. And for the time being, I'm kind of just, you know, scratching something together. And we can probably write a header on here that says, hey, this declaration is a world type. And then it should have, the moment I say it's a world type, you know, like a zone, it'll say, okay, these are the data types that I should be parsing, you know? And then it's just a line reader. Hey, Fanar. Hope you've been doing well. Long time no see. I hope you are improving on your skill in programming since you last streamed. Yeah, I guess you could say that. Always improving on my programming. Hope you've been well. It's what? I got like 10 minutes, give or take, and then it'll be 2 hours. Woof. But for the time being, I think we're getting decent. I know this is all kind of like theory code for now. I could actually write a test file real fast just to sort of see what this looks like. Package WAD func test WAD write. Yeah, you know what I'm doing. Boop. And will you auto generate it all for me? No, you're doing weird shit. I don't need parallel or any of that. So we'll just make a new one. We're going to call it W is a new WAD, right? And then W write to W, or I guess W is not a good word. Let's do WAD. So WAD, I want you to write to W, and then W error is, I'm actually going to write it to a buffer. So buff and yeah, that works. I like it when it fatal F's on failure. Yeah, that works. This will be enough. Obviously, this will just do nothing, basically, because there's no data. I also want it to just print whatever the buffer has. Yeah, exactly. Which in our case has nothing because nothing is defined, I guess. Which arguably, even if nothing's defined, you should get some of these lines. I think I have to flush the right. So let's do a deferral and just say W flush. Wait, does writing need a flush? I don't think it needs a flush. Why didn't it write this? Interesting. I'll breakpoint on the debug and see what buffer has in it. It's empty. Why are you empty? I told you to write. Are you just erroring or something? Yeah, like you literally are trying to write there. And so W, which is the buffer writer, should now have, yeah, see, it has data. So what did I do to screw this up? This is just doing a write in return. So if we go to the end, you should be full of data. What do you got on you? Yeah, see, you got a length of 4096. You got plenty of data in you. Then why, when you return, yeah, you have lots of data in you. So why aren't you writing? Oh, is it because I'm... Well, no. It could be I need a flush. Let's try that. Let's see if that fixes it. Yeah, I just didn't flush the data on the buffer. I've been good since last time I seen ya stream. I got 6 teeth extracted. Holy crap. Besides that, I've been improving on taking better care of my teeth. Probably a good idea. That's a lot of teeth extractions. I actually just recently got a root canal, so you're not alone in the teeth problems. But yeah, that sucks, dude. So you see here, there's a generic, write out of the file. And obviously there's no data yet. That's why it's all empty. So for fun, we'll make a bitmap, sure. What do you got for me? There we go, test. I like it. Make me data. Gotta love Copilot. Make me a material. There we go, that works. Looks beautiful. Give me all those values. Yeah, make me a DM sprite. Why not? Is this actually correct? I don't think normals and stuff have been defined. Did I get that far? I feel like this is just getting a little ambitious because bitmap info, DM sprite info. Oh, I did. Wow. But it was all auto-generated, so whatever. So let's test this. Oh, we got some errors on compiling. Yeah, you should be bitmap info, right? And it needs to be an instance. Same with you. You tried. What are you doing wrong? Cannot use... Why not? Sprite. DM sprites is DM sprite info with an array. Oh. It's because this is literally sprite. And instances is going to be a pointer. Pretty sure I'm just missing pointers. I didn't do so good on discerning that for me. I think you're info. Yeah. Same with track. And it doesn't like textures. Why not? Oh. Number of textures in bitmap info is not defined. What do you mean? What did I call it now? Let's see. Yeah, it's called textures. It's right here. Bitmap info has textures. So why are you unhappy? There's the textures. Material list. First of all, why are you material? Oh, wait. This is my old world rod. I can take this out. This is my old code. That's why I was unhappy. All right, what do we get? Looking good. So, as you can see here, it generates a CPI world. I gave it a little generic name. And this is like, if you compare this, can I copy this? Thank you. Can we move you down or are you stuck? Okay. All right, let's just close you, come over here. And now we can kind of compare 1-to-1 and see how. Hey, you collapsed. I didn't mean for you to all be collapsed. Can you expand all? What the heck? Get that crap out of here. I just want, there we go. All right. So left is the original WAD from Tanaris, and right is my generated one that I'm kind of theory crafting right now. So bitmap info 0, technically this needs to be tabbed. Let's go ahead and fix that real quick. Where is world right? There we go. Or WAD right. And then this needs to be tabbed. Where is output? Copy you again, pop you over to, we can close you out, close you out. I'm out of like real estate with this weird. There we go. So you can see here, it's like, there's a little tab. My tabs are bigger. Are these spaces? Oh, I could do spaces, I guess. So let's just convert all tabs to spaces. Let's run this again like this. Okay. So CPI info, there would be a comment. Then there's like a default palette, and then world vertices, and then number of vertices. In my case, I go right into number of bitmap info. And then this is a declaration of bitmap info 0. And this is similar to like here, number of BSP node 0. But then this needs to be tabbed. So all the ones after bitmap info, like here, need to be tabbed. The U need to be tabbed. You need to be tabbed. Oof, this is gonna get gross. Because all these are gonna need to be tabbed. Let's test that and see how it looks. I probably should write like an indenter or something, you know, like to keep track of this. Because this is gonna get gross otherwise. Oh, end texture needs to have the index. Thank you. And what else am I missing? Texture and texture. Yep. 2D sprite tag. Here's all the definition flag data. And NTD sprite instance. That looks good. Material tag looks good. And bitmap info. Yeah. So technically though, is this tabbed on this one? Yes. Cool. All right, catching up, guys. Sorry, guys. I gotta say, getting 3 of my front teeth extracted was the most painful part of my life because they were so badly eroded. Yeah, I stopped drinking soda like 2 or 3 years ago, and just kind of avoid acidic things, especially lingering in my mouth. The next time I see the dentist, I will get fitted for dentures, which my insurance will cover. That's always good when the insurance covers it. It's probably easier to have an increment to yeah, and custom print function that takes that into account. Right. And I mean, what I could even do is write functions that do each of these like nested elements and just have each of those nested elements have like an argument of where you're at in the indentation, you know? But for the time being, this is just like a prototype and it technically works like this. There's a little bit more spacing, I think, on this one. Like they like to space after certain definitions. And that probably would make sense for us too. So like, heck, what I could just do to simulate that is just do, you know, little chunks. So like, I think this one has one, this one has one, this one has one. That's a quick and dirty version. But let's see how gross that makes it. Oop, I guess I'm double indenting now on some of these, which is interesting. Why was that happening? Material tag after no materials is, where's material tag? Oh, I do that. Oh, no. I don't need to do quote and because that's double. Let's just do that. That'll do it better. There we go. Maybe. Wait. Why is it still double? I screwed that up. I missed them. There. Eek. That wasn't what I wanted. Oh, it's because down here, there's a new line right here. There. Okay, wait, I still have doubles. Why? Where are these defined? You're fine. Oh, okay. Let's do this. No, just this part. There we go. No, why do you delete you? Don't do that. Copy, paste. Much better. Now num sprite info has a double line. Num dm sprite info actually. Why do you have a double line? You just have a new line here. Might be just because of the end of the sentence. Hey, Twin Cannon, how you doing? I'm having fun writing some Quail WAD file stuff, whatever that might be. And I'm about to end, unfortunately. But nice to see you, dude. Yeah. I feel like this is probably the right direction. Obviously, like these end textures and the num textures, it's a little off. But I can see where this could become a lot easier to parse in Python and even easier for me to parse. And I mean, look how easy these files are to work on. So when we get this all done, you know, if you wanted to add a texture, you would just go 3, you know what I mean? And then put a texture here. And that arguably should generate a WLD from this. So like, I feel like my first goal should just simply be a read write of WAD in Quail. And if I can get this like perfect, that already can be useful because you could always load in like, you know what I mean? A world file, go in here and start modding it. And it's a lot easier to work with than this. This is like a mess. Not to say like this is going to cure cancer or anything, but this should help, I think. But we'll see. Who knows? I feel like it's a good little mini project though. But yeah, I think we're going to start ending the stream. Let me go ahead and close out. Got a lot of local files I need to commit at some point, but if you've been watching, I hope you've enjoyed. Here's my end stream scene. Let me show you this real quick. Beautiful, isn't it? Whoops, as I overexpose. Let me read what you're saying while I kind of wrap up. There are some leftover source files inside the S3D files. Do you have any references of those in Orlean? Do you have any that actually have WAD files? Because that would be massive for me with what I'm doing right now. So let me know if you find one. Because I'm very interested. But I do know that like there's some PRG files and there's some other random kind of intermediary files, especially for like modern zones. Drachnic Hide is one classic one, or the Hive or whatever it's called. Globalo doesn't have the WAD files though. Yeah. But anyways, well, thank you guys for watching. I'm going to try to stream more often and hope to see you soon. I'll do more EverQuesty stuff. Probably expect me to work on this WAD stuff for the next couple days, give or take, when I have time. And then we'll switch over to some documentation things. We have that list that we were talking about in client-side mods that might make sense to go over. Yeah, dude. Thanks for hopping in, Fanar, and I will try to make sure. I got a setup now where I can be on like my really comfortable desk and not on my streaming desk. So in 2 of the global lists, there are leftovers. Yeah. So, all right, Anarian, thank you again for your help, and thank you everyone else for watching, and see you next time. Take care.